I'm glad I didn't record that last part. Probably evidence number one when they fire me. Anyway, so yes, we're going to talk about GIS and we're going to talk about joins, queries, and data sources. So remember one thing I was talking about when I opened up talking about GIS is that one of the most powerful things that we can do with GIS is actually pull together multiple data sources and really start to make them work together for the common good of you finding things out in the world, which is good. And so that I'm really going to try to emphasize. This is a part that really kind of pushes that more so to that direction, is to perform joins, which joins are really database functions that are common. However, that being said, we do them slightly differently in GIS. First off, there's nice automated tools so you don't actually have to write like the SQL language itself. You just use little nice dialogue, so I'll talk about that. And these are generally, in theory, the same, very much between different. Actually, I went back and checked up with ArcGIS, and actually a lot of the terminology of the specific things that you put in QGIS are exactly the same as in ArcGIS. So if you move to ArcGIS at some point, this is going to be very similar. So let's talk about what joins are. First off, joins are just combining data from different sources. Usually, if you're doing this in a database, is going to be data from two different tables that you are essentially aligning, so to speak. What's the real? Anyone here work with databases? Someone, do you remember what the term is for what you're doing? Okay, that's fine. Anyway, so combining data from two different sources, and essentially you're using some sort of common field to be able to assign these so that you know they're coming from some common entity. And there are two different kinds that we can do in GIS. So one is just a table join, and this is very similar to what you do in any database, but also we have these special ones that we can do in georeferenced databases. We can also do a spatial join, so that we are actually not combining them on some unique field. We are combining them based on their physical placement in space, which is kind of nice and powerful. So we'll talk about the simpler one first, the table join, and then move on to spatial joins after that. So table joins are actually one of the nicest and easiest ways that you can get new data into GIS, like data that you're getting from other sources that you're collecting yourself. Hey, I am working that in a little bit. Your own data. Okay. Cool. We'll also talk about the other things. And that's one of the easiest ways to get that data into GIS. So, and really what we're doing here is we can join data from a non-spatial data set, something that is intrinsically not georeferenced. Now it is spatial because you need to have some way to point it to something in space, but it doesn't have to be georeferenced in the same way that the rest of your geographic data is. It doesn't have to have X, Y coordinates so we can actually put it on a map somewhere. It could be referenced like, what are these counting names, or something else like that. And the process of this is pretty typical. You're going to import the table in typically something like a CSV or something else like that. And then you're going to connect it to a layer in your GIS by some identifying field. And then what you can do after you do that is pull columns then or fields from this database or this other data set you have into the attributes table of your specifically georeferenced layer, your vector layer that you have. So let me give you an example of how we could do this. I will go down here. I should still let that open. You are slow. This is a slow dance. You're slow. I mean, not in a way that's like, if I'm doing this to you, I'm not like, slow. Go faster. Which is 2.1. Because I think QGIS is developed in Europe, and then they just decided to use cities. I don't know. Okay, so let's go ahead and open up a layer that we've been using before. Add a layer, and we're just going to pull back in the counties of the state of Washington, which is, hey, that's a good one. Do I have it in here? No, I think I have to go back to lab. I had it in lab. Here's all the data I was going to think about making you guys work with, and then I decided to only use one of them. And then, yeah. You open this up, and then we have Washington again, and here's down our layers, and that's all wonderful and nice and good. Okay, well, I was out. I was kind of interested in what happened in the last election. I have here, this data right here, is I have the CSV that came from the 2012 election that has a whole bunch of things about voter behavior and stuff in it. It's kind of interesting. And it's all divided up by county, and if you come up, it's just a CSV file. Everything's slow. It doesn't help, I don't think. Oh, here we go. It's actually open. Here we go. So what we have in here is hard to see, but we have like county, active voters, inactive voters, ballots returned, the turnout, ballots counted, ballots rejected, discrepancy, probably, all this stuff about votes in the last presidential election, which is kind of cool, and it's divided by county. So this is, in some ways, fundamentally spatial, but we don't have, it's not actually joined to any CSV, or it's not joined to any vector file. And this is just something that's freely available. I just went out looking for some data. I was like, oh, hey, the Secretary of State for Washington probably has some. He has all this. That department, the Office of the Secretary of State, has a lot of this just CSVs that you can go just download for like any number of past elections, and also voting results and all this. It's cool, and this kind of data is available all over the place. However, it's hard to visualize spatially because it's not actually done that way. It's not set up as like a vector file or anything. So here's what we can do, is come back into here, and we can load this into R as just a table. And how we do that is we add layer, but instead of doing vector or raster like we did up here, we come down to add delimited text file. Go ahead and click on that. And then we can come in here and we just browse over to it. Here it is. And then we select things. Like number one here, we have is a comma-separated variable file. Perfect. We have options and field options. We're going to leave most of this the same. But here's one thing, geometry definition. There is no geometry in here. And it asks us for point coordinates, and we can actually come in here, and this is hard to see, but you have X field right here. And we can actually choose which of the columns in here was an X coordinate, which one was a Y coordinate. So we can actually pull these in as points. But there is no XY coordinates here. So we just go over here to this last one, no geometry. Is an attribute table only. Hit OK there. And then we go ahead and bring it in. And so now we have it, and we can go in here and we can actually open the attribute table, and here it is. Just like you're to pull in a CSV into like Excel or something like that. We have counties here, active vote, inactive votes, all this cool stuff. Let's imagine I want to look at and visualize turnout, like voter turnout by county, and see what counties are doing their civic responsibility the best. What we can do is we go in here to county, we'll look at this attribute table real fast, and we need to find some way in which we can identify the records in that attribute table that we pulled in to the attribute table that is in here for this counties layer. What we see here is we have two different names for counties. We have one that just has the name, and then we also have this one that has something county like that. Woo, look at that. All happy. So if we go back and look at our other attribute table, we'll look at how it looks in there, and okay, so it is like King County, Jefferson County, Columbia County. Okay, so we need the double county. Now, oftentimes you'd look at this before you pull it in, just kind of make sure, and if this didn't match up, like for instance, imagine we only had the things in the other table without the county on the end, and we only had the ones with the county on the end. This is something that you could solve really simply before you pulled it in with like regular expressions, just to delete the county after everything, or something like that. But in this case, we don't have to worry about that. So what we do here is we go into here, And we come back in, just double click and bring up the properties for that layer, like we were messing with in lab a whole bunch. But we're mostly messing with the style here. If we come down here to joins, what we can do is add a join to another table. So we hit the plus down here in the lower left-hand column. And the join layer, we have both the layer to join to and the join field, which we want county in that layer. And we're going to target, which one does it count to? It was the name L/10 is the one that was. And then I don't want everything, I just want one particular one. I want to look at turnout, so I'm just going to do turnout. I hit OK. So now I've made this particular join that is joining this layer, this counties 10, to this other layer, and we're identifying them by the county name, and we're aligning that with the county name in here, and I've only now pulled in that one particular data set, or that one particular column. So now if I go look at the columns here in County 10, or the attribute table, I look over here at the very end, and now I have this one. It's called a little bit different. It's but this is the voter turnout from that other data set. So now we actually have pulled that into here. It's a really easy way now to pull in data. So let's actually do this real fast. Color this by voter turnout real fast. I'm going to go style, do a gradient, do this by... And again here, if you look at it close, it's hard to see, but actually reads the whole thing. It reads out the table that was pulled from and then actually the column. So it's 2012 General Reconciliation by County Turnout. Yeah, let's just keep it 12 classes. Let's do it by natural breaks. Okay. And then precision, I want this only to go down to. Okay, and hit OK. There we go. There is the county shaded by their voter turnout, and it was actually really easy to pull this data in from somewhere totally different and map it like that. So this is again pulling in some of the more interesting ways of using GIS. Okay, so that is how table joins work. Really, we're taking non-spatial data and joining it to spatial data so that we can use something spatially to look at, in some way spatially. However, we also have spatial joins, which are also really, really useful. And this is joining data from two different spatial data sets based on their spatial data, which is really kind of cool. So imagine you wanted to summarize attributes from one data set by how they were organized by another data set. So for instance, we want to know how many hospital beds there were by county, kind of harkening back to what we were doing last time. Or one thing Mo tried to do yesterday, which we almost got to work. By the way, I got that to work after I went home. I was like, I can get this to work. I got to work. How many wetlands are there, or was the area of wetland per county? Because you pulled in a wetland file. So what this does is this is going to identify features based on the relationship to other features and then select them. So we can do this by how are they intersected, which ones are contained within polygons of another one, something like that. And this will become a little bit more clear as I actually demonstrate this. And then we select them, and we can do several things with this. We can create new layers, we can tabulate the data, we can do other things like that. So let's do this. I'm going to sit down here for a second. Okay, let me pull in now. I do not want to have this all. I'm going to get rid of this one just to keep it all nice and clean. Remove this other table. Actually, no, I'll just pull in this other one. Okay, so layer. Let's actually look at that hospital's data that we were looking at before. Where did I put that? Yeah, that's in the lab data. So come down into here. Oh. Hospitals. Actually, cancel that. I want actually directory. This is going to be a GDB. I forgot about that. lab here, data, and then we have the hospitals database. Okay, pull that in. Okay, so there's all of our hospitals. Let's make them something cool and red, actually. For the moment, red stars. Yeah, let's make them red stars again because everyone likes hospitals with red stars, right? So there are all of our hospitals, and we actually look at the attributes table. So we looked at how many hospitals there were per 10,000 people or 100,000 people. But here's a problem with that intrinsically is, like, some hospitals are bigger than other hospitals. That kind of skews everything. And I know that, but, you know, we're dealing with what we could do at the moment. But if you look at the attributes table for this, actually what they have in here is the number of beds, the number of different kinds of beds. Beds ICU, bed nursing, bed chem, I don't even know what that means. Psych, acute, beds total. So here's the total number of beds that they have in each, what are they called? Hospitals. Thank you. Hospitals. So this is kind of interesting. What would be even more interesting is then looking at how many beds does every county have. That's much more useful than how many hospitals they have.
That one on the top has more psych beds than those beds total.
Yeah, I know. I have no idea. Okay, so here's one thing. You have to double check things. But let's imagine that they knew what they were doing for some odd reason. And the reason for that has something to do with them coming as psych beds. That was supposed to be a joke that I totally ignored. There are 5 lights! Never mind. Okay, here we go. I'm okay. So let's imagine I want to find a way to figure out how many beds are there per county rather than just how many hospitals are there per county. And what we have to do now is we have to do a spatial join to do that. We have to join this data by its spatial properties. There we go. That's a word. Properties is a word. I swear. We go in here into vector and data management tools and join attributes by location. So actually, here's our target vector, kind of 10. Our joined vector, we want hospitals. And we're going to take the summary of the intersecting features. So I don't want the mean of the beds per hospital in there. I'm going to unselect that one. I want the sum of them. I want how many are there. We're going to make a new data table here, which is, oh yeah, I need to browse to it. Hospital beds. Okay, and we want to, keep only matching records. And then we hit OK, and it's going to, they're not, okay, yeah. And it's going to do it, OK. And here we go now. Again, we have those 3 weird counties that don't have any hospitals in them, so they like just drop out the data. But then we open the attribute tables, and now we have everything, the sum of everything that was in all those other layers. And I don't really care about most of this. I just want the sum of the beds total, which was right here. Oop. Yeah, so here we have, if I make this wider here, actually, sum of the beds total, and now we have the sum of how many total beds there are per county. And now we could run through that exact same. I wish I could just highlight things in here, because I totally lost it already. Okay, yeah, here. So now we have the sum of how many beds you have, and now King County, instead of just having 29 hospitals, has 4,931 beds. And so we've taken all of that and summarized it by how it's spatially organized via another layer. Are there any questions on that so far? Okay. And then we could go, actually, let's just shade it by that. Let's do this. I want to actually go the whole distance that we did with this. Let's go per 10,000 people again. I don't know, because why not? Output field name. Beds per, let's say 1,000 people. Yeah, okay. So we go fields. On the sum of beds total. And we're going to divide that by the population. Take that whole thing, multiply by 1,000. Oh, by the way, it does give you like a preview of your first output here. And so that you can get an idea, it's just like normal. So my first output was like 2.4. If I do 100,000, like we did before, it's 240 beds per 100,000 people. If I take it down to 1,000, 2.4 per 1,000, that like seems like a good number. Okay, so beds per 1,000. I want this in decimal, number of real. Oh, I figured out why this was like truncating all of yours to whole numbers. Did you find this out too?
I did find this out.
It's precision here. Our precision is 0, and this actually means that we have 0 decimal places. So actually, let's turn that into precision of 2, and that will give us 2 decimal places after each. That makes more sense. So that was the problem there in lab. We hit OK. It should update. And now if we go to the very end of this, hey, we have now beds per 1,000 people, which is kind of cool. And we have some that are high as 11. And we have some as low as 0.32 beds per 1,000 people, which is, and some 0. But Franklin County also seems like a little understaffed with only a third every 1,000 people. Maybe people don't get sick there. I don't know. Yeah, who has 11 beds for every? Garfield County. Wow. That's like right next to here. That's over in Pomeroy's in Garfield County, right? Okay, let's save this. So we go save this. Let's shade this by that. I'm going to totally take this out. Let's go back here. Let's get a gradient here. I want this in natural breaks. I'm going to do this by beds per 1,000. Classify. Okay. Hey. Yeah, there's Garfield County. Crazy place. But hey, we're doing pretty well here in Walla Walla too. And yeah. Okay. So that is a spatial join. Again, we're joining and uniting data based on how it's spatially organized. And let's do another thing. So let's go ahead and take this out, put this back in, and I'm going to open up, cancel that, layer, add layer, add vector layer. It's in here. Oh yeah, let's do this. Directory. I'm gonna get this loading while I talk about the next part. Oh, I don't care about that. I care about this. Let's load cities. So we have a thing that has like the major cities in Washington. Open. So there is cities. I want to just make this like. That you can't see it all. I don't care. I'm gonna open. Oops, I don't want. Okay, a shapefile. Okay, so I'm loading in like the city limits in Washington. I'm also loading in wetlands, and wetlands like are like all over the place. So we have tons of them. So imagine what I want to do is, unless this actually is, no, you won't notice that. So if we zoom in here, what we can see is like, hey, like there are wetlands in Seattle. Who knew? And if we come in here to Walla Walla, here is Walla Walla College Place. You'll notice there are a few wetlands actually, and this is over this when you actually pull this down here. There are some wetlands here in Walla Walla as well. Doesn't look like any in College Place, but you know they're kind of around. So imagine now, if you will, wait, did I actually? Yeah. Wait. Go back to the spatial blur. Okay. So we want to find how things are intersecting. We want to be able to select certain things by certain polygons by, or points or whatever they are by, if they intersect, if they're contained within, other things like this. So what we can use is a spatial query for this. So imagine what? Okay. Oh, that's why. Because now, imagine I want to just select all of the wetlands that are within city limits, or at least partially occur within city limits. I want to grab those and I want to make another layer out of those, or something like that. What I can use is this tool over here, which is Spatial Query. Open that up, and we get a tool that looks kind of like this. And we want to select source features from the wetlands. And we want them to be, let's say, intersects, so they at least have some part that is within, or some part that's intersecting with, not hospital beds. How many wetlands are in hospital beds? That sounds like a joke budding, but I have not been doing very well with jokes today, so I will not even try. We want how many wetlands occur within cities, and we want to create a new selection. So we do this, we apply, and then it actually takes forever to process, because there's lots of wetlands, and there's a decent number of cities in Washington, so it's going to sit here and think about this for a while. While that is going, I'm going to talk about something else. So, someone brought up to me that it might be interesting to know how you get your own data into GIS. How do you create your own data? And one of the things is using a table join. You have a table of your own data, or something else, and then you can join it to an already made spatial reference file. There's a couple other ways to do this as well. So actually, one way that you can easily collect, if you have the thing, is spatially referenced data already, is to use a GPS. Like, so for instance, imagine I want to go out and find a bunch of points of where I'm finding like frogs in the forest. I start walking around the forest like this, and I find a frog. Frog! And then you can go into most GPSs and designate anything called a waypoint. And so, like, you go through and you actually and it puts like a thing right there. And then I go on, I keep looking for frogs. And I keep doing this, I'm surveying. Imagine I have some systematic way, and I'm finding frogs, and I'm waypointing them. In most GPSs, there's actually this kind of nice generalized exchange format for that data. You can export this as what's known as a GPX file. That GPX file, then, you can pull into GIS. Actually, most GIS platforms, including ArcGIS and QGIS, will import GPX files as a vector file. So we can upload those waypoints as point vector files in GIS, and then use them the way we would any other points. Also, most GPSs will keep track of your tracks. So, like, they will keep referencing where you are every second or so, and then connect those into essentially a line with vertices. And you can load those up as GPX files as well. Export them from the GPS with whatever software came with the GPS, hook up to a computer, of course, and then load those up, and you can get line types into this that way. There's one thing that you can do with vector files then, and I'll show you as soon as this gets finished, is that we can then turn those from lines into a polygon. So imagine I want to get the limits of the campus, and there's no, like, I want the campus boundaries, right? And there's no good way to get that otherwise. Well, there actually is another good way. One way that you can do is you actually go out and actually walk the boundary with a GPS. get it to record your tracks, and then turn that into a shapefile. Export as GPX, import into here as a shapefile, and then turn the line into a polygon, which I'll show you how to do in just a few months when this is free again. The other thing that you can do is actually you can just make new spatially referenced files by drawing boxes and things inside here. So let's show you how to do that. Okay, I'll come back to that in just a moment. Okay, so what we have is now selected 7,952 wetland polygons as being inside or occurring at least partially inside city limits across the state of Washington. That's a lot. And so now all it's done is selected them. It hasn't done anything else. So we're going to have to close this. They're still selected. So now, if we look at here, this is probably hard to see because remember how things turned yellow when you selected them? It's hard to see, but this is kind of brownish and this is yellow, but everything gets washed out. So this is not inside city limits. This is inside city limits. Let me see if I can actually change that here. Let's turn this to not a yellow thing. Let's turn you into a green thing, maybe. Okay. Let's turn them into red things. Come on. There we go, right? Okay. So this is not selected. This has been selected. Okay, so now we've just selected it. There's several things that we can do with it. We can do queries based on that. Another really useful thing is that we can come into this layer, just right-click on this, and go Save As. And as we save it, you've done this before. You can save it as a shapefile, but in encoding under here, we can go Save Only the Selected Features. So what this will do now is save only the features that we have selected, which is only now those wetlands that partially occur within city limits of Washington State. And that becomes its own layer, and then we can do other things. We can do other spatial joins based on that or now. So this is another way of subdividing and subsetting your data, doing stuff like that. Okay. Cancel this. We're getting short on time. Go back in here to vector, and here's another one here. Geometry tools. I talked about how you can turn lines into polygons. It's right here, lines to polygons, and this will allow you to convert a line feature, which would be like a track from a GPX file or in GPS. You can turn them into a polygon here using these vector tools, and that's similar in QGIS or ArcGIS. And one final thing, another thing that you can do is actually, I don't know how to do this in QGIS. I know how to do this in ArcGIS because I didn't look it up in QGIS. Random thing, I've actually never used QGIS before this week, so I'm kind of learning it along with you. I've used ArcGIS a good amount, but this is the first time with QGIS. Saying that, I don't know actually how to do it, but there are ways in essentially all, and I'm sure it is the same here, GIS, is that you can actually draw boxes or draw awkwardly shaped polygons and make them into layers as well. So that's another way that you can get your own data or things that you're interested in. And that's actually probably a better way to mark the boundaries of Walla Walla University instead of walking all the way around. It's just that your computer can actually draw the polygon around it. But you know, maybe you're in the forest and you need to walk the perimeter of a timber sale, which is the kind of thing I've done before, something else like that. Okay. With that, we should move on to things that are also happening. Oh, I'm going to go through this really quickly, because I also had this really quickly. So some places to get GIS data sources, they're basically everywhere. So one of the nice things is oftentimes you don't need to make your own layers. You will need to make your layers if you're collecting your own data. But then a lot of the other reference data that you need to apply this to is going to come from all over the place. It's prolific, it's out there. You start looking, it's hand over fist. And like you were seeing earlier, yesterday in lab, a lot of local governments will have pages that outlet a lot of the stuff that they collect. So for instance, you saw Walla Walla counties and the state of Washington's. However, federal government has a ton as well. U.S. Geologic Survey has a clearinghouse for their geographic data. National Oceanic and Atmospheric Administration, NOAA, has one. U.S. Forest Service has an outlet for all their geographic data. U.S. Department of Fish and Wildlife. Center for Disease Control has a really interesting one as well that has lots of interesting data on prevalence of disease and incidence of mortality and other cool things like this, all spatially referenced. So cdc.gov/GIS, yeah. Also, there's a lot of really interesting third-party places. One that I have used a lot before is geocom.com. But honestly, most of this is actually government sources, so things that you can also find from like USGS, but they've been subdivided in more useful ways, and they've been categorized in ways a little bit easier to get to, so that's kind of nice. And there's a lot of academic and scholarly places that outlet GIS information pretty freely as well. Dryad, again, this is a digital repository for data that has been published or published journals and other things like that. And a lot of people deposit their data there. So, like for instance, GenBank is where people deposit their genetic data. That's a really useful one. But there's lots of other non-genetic data that's really important to get access to. One of those is all the GIS data. So the place that most people are depositing their GIS data is Dryad, and then university websites. So for instance, I was just poking around, and the University of Washington has this place that they are outletting a lot of their GIS data. So it's prolific, it's everywhere, it's easy to find. So, okay, she's all done. So before we do this, or as we're doing this, I want to do just a couple things here. And one of them is to make sure that you are informed about what you're doing. So I have a informed consent form for you guys to sign for me. But kind of illustrating what is going on. And in short, I will summarize what's happening. We are going to take cheek cell speed. You are not required to do this. You will in no way, your grade will not depend on you doing this or not doing this. If you, 1, 2, 3, 4, 5. 5 is a hard number to count to.
You understand? Yes.
Yeah. Go. 4. And then 1,
Do you have a writing utensil?
2.
I don't have a backpack today.
You go. We're missing one person. I don't know who that person is. So, essentially, here's what's going to happen. We're going to collect cheek cells. And then you do not have to do this. We are going to then sequence. Actually, thank you, Leah, and whoever you recruit to help with this, but she's going to be doing all the PCR this afternoon, and then amping. Wait, that's the same thing. And then cleaning up, and then sending off for the sequencer. We're going to sequence your mitochondrial hypovariable regions 1 and 2. These are not under selection, which means, or under very close to neutral selection. I don't think anything's truly not under selection. Anyways, but which means that they accumulate mutations, which means that there's essentially no medical information in these sequences. There's no relationship to any known disease as far as I could find, and it's unlikely that there is because they're not regulatory or coding for a protein or anything else like that. However, there is heredity information in them. You can tell something about heredity. Now, that being said, this is mitochondrial DNA, so it's only through your matrilineal line. So this is only coming from your mother, from your grandmother, from your great-grandmother. This tells you nothing about the male pattern of inheritance in your family. All that being said, this generally, I believe, is low enough resolution that you can't like say, oh, so-and-so is my brother that I never knew about from this, because it's not to that level of resolution. However, that being said, there is a small possibility that you could find out that you are not related to, because you can say, oh, I am not your brother, or something like that. We do not share the same female ancestor that we thought we did in the very recent past. Although that being said, that's not strictly the case either. Even if you come back with a different sequence than someone, there are things like heteroplasmy, where people can carry 2 different sequences of mitochondria along in them and pass 2 different ones off to their children. Because actually the mitochondria in you are not just a single mitochondria, it's a population of mitochondria, and you can actually have, they are diverging inside of you at this moment. Anyway, so that's kind of interesting. So all that being said, we will be using this as a class. So your sequences will be available to everyone else in the class. So there is that. If you do not want that to happen, like I said, you don't have to participate. That's A-okay. There's nothing that will happen to you for not doing it. It's fine. Okay, let's see here. There are potential advantages. You're gonna learn things about using sequences. You're gonna learn things about your own sequences. It's kind of cool because you can like place yourself in like the large human lineages, which is kind of neat. There is no, we're not gonna be keeping these confidential. So however, that being said, at no time are these gonna be available like publicly. Like they won't be available on servers that anyone from the public can get access to. So this shouldn't be publicly available, but it will be available to other people in the class. And if at some point you decide, hey, I want to do this now, but you reconsider and come back later and say, I don't want to do this anymore, we will delete your sequences and we'll do everything we can to make sure as if it had never happened. Other than, it'll be really hard if you punch a toothpick through your cheek to make like that never happened. And yeah, all your biological material was going to be destroyed after we get the sequences, so we're not going to keep your cheek cells around to do other things. Are there any questions? Okay, with that, you want to help me?
Make sure you guys keep track of what number is on your tube, so that we know which tube is yours.
Yes. In fact,
Or should we have to write it on the board?
actually, I'm going to do this. I'm going to make a, right after class, I'm going to make a Google Doc with numbers 1 through 26 in there, and if you can put like your name next to whichever one you did. Yeah. Okay. This is buffer. You are going to, actually here, pass it around, take one. That's a lot easier.
Do you need help?
I'm just going to have them pass it.
Okay.
Here's a toothpick, go ahead and take it. They don't need to be sterile because, I mean, we're not culturing anything, so we're good to go. Once again, take the toothpick, try to scrape your cheek as much as you possibly can and get as much gunk from your cheek as you possibly can get. And then put it down into the buffer, swirl it around so that you get all that gunk off into the buffer, and then, like inside your cheek. Scrape around the inside of your cheek to get epithelial cells from the inside of your cheek. Pop it in there. And the idea is that we will have these sequences back ready for you to use by lab time on Thursday.
Yeah, 6. That's 6.
I have no idea.
If in doubt, do more.
Sticking with the I'm gonna forget.
I feel like I scraped my cheek.
And yeah, again, remember your number. And hold on, let's get that back so we have something to put it in before. Yeah, that should be fine. Oh, she's gonna go get ice. I'm gonna put these on ice. Okay, I'll read through the. Okay, here we go.
I put in a work order on Monday.
Okay.
And they still haven't fixed it.
So here, let's put these ones over here. 1, 2, 3.
Those ones that haven't been
Yeah, these are ones that have not been
used.
used.
This is to go downstairs.
Okay. I did not even know there was missing And then once you give this to me, go ahead and you're good to go. But do remember, I will send an email about the whole word to bother your numbers with. And then, yeah, go ahead and give me the informed consent things up here as well. Thank you.
Are you putting them? Oh, there's no ice. Just kidding. I answered the question.
Was the word you were looking for repository?
Repository? No, I was looking for a depository. Wait, what was his name?
You were asking for
Oh, no.
I go downstairs.
Knock on my door, my bedroom door, and my brother's name.
Where did we, I don't know, we didn't have this stuff, right?
Okay, I'm gonna, I'm gonna have a Google Doc.
Okay.
I'm gonna make a Google Doc and I'm gonna email you all about that.
Wait, sorry, I couldn't understand
I'm
that.
gonna make a Google Doc and then I'm going to email you all y'all. Hopefully there's enough.
I know.
I know, so literally I hope if I'm going to go to the police or my dad, and then I
think
had
there
to
will
find
be.
my back canvas.
Actually, you can kind of see it all like floating around in there.
Yeah.
I think I have a question,
Yeah.
but I can wait and tell you guys.
Okay. Okay, I am number 14. Here
I will, maybe I will drop it off there.
we go.
What if I participated but refused to sign the consent form?
Then we won't sequence anything. Like we take it and then we just want to sequence it because you haven't given our consent to sequence it. So we're not going to do something that you don't consent
Yeah,
to.
but are you actually going to double check all of them?
Yes. I had to go through quite a process to get this approved.
No, I believe it. I was going to be doing human testing,
More the better,
except
right?
it wasn't worth it. Plus, I would have had to rewrite my grant.
Oh, yeah. That is a thing too. Well, Cleo, then yes, then back here. She was.
I just have applied 6. I don't know how to do the second half of it.
Okay. Remind me what the second half of 6 was.
So it was object tracking. So you find the length of the pole's track.
Yes.
Then you're trying to find the speed and velocity. Like, is that something I need to calculate outside of ImageJ?
Yeah, you're gonna have to pull it out and then do it in something like Excel or something, and then just use like the distance formula between sequential points.
Okay.
Yeah.
So that's where I was like, I'm supposed to be trying to find.
Yeah,
this
there's nothing in
ImageJ.
ImageJ. Yeah. The point was just to kind of take it to the next logical
Okay.
step.
That's where I was like, I can't find it in the program.
Okay.
Oh, it's Nancy.
Jody.
Yeah.
What's that? I do not. I have a meeting at 10. Yes. Do you have anything at 11? Okay. Then I'm out of here after 11 to noon. I'm out here. Monday. Monday would be the
I'm
next
gonna
one.
tell everyone to remember what is your number? 24. Okay.
Yes. Yes. We do that. Okay. Cool. Sorry, I'm hard to get hold of. Okay.
Number 6 wasn't used, I think.
Yeah.
And Nancy's the one that's not. Yeah, Nancy's.
Oh, Nancy. Okay.
Yeah.
Maybe we could. Is she like gone?
She went to basic training graduation.
Okay.
Yeah.
I guess I'll. However, that being said, if you were willing, if she's here on Monday
It's Monday morning.
to do it like really quick before you send it out,
Yeah.
how long does the whole like PCO is gonna take a few hours to
Yeah.
like run. But all the other steps, like you just sit down and bang them out. It's pretty
Yeah,
quick, right?
especially if I just.
I'll talk to you later, Matt.
Yeah. Like I was planning
Yeah,
on
if you didn't want them on a
checking-
gel.
Yeah, I was
Yeah.
planning on checking everyone's on a gel. I guess it doesn't really matter, but I think we have to figure out dilution. So
Yeah.
which I have to talk to Jill about. So if it'll